Example 1, identifying functions. Math with Mr. Williams. Does each table represent a linear or an exponential function? Explain. So here we have the first table. We have x's look like they're increasing by 1 each time. And we have down here for our y, it looks like it's a constant here. And it looks like it's increasing by 2. Okay, so as the x increases by 1, the y increases by 2, the rate of change is constant. So the function is linear. The key part here is the addition. This makes it an arithmetic sequence. In B, I can see my x is increasing by 1s, but I see my y is not increasing by 4 each time. It looks like it's going to be using multiplication. So I see, how do I get from 4 to 8? Well, it looks like I'm going to multiply by 2. How do I get from 8 to 16? Multiply by 2. How do I get from 16 to 32? I am going to multiply by 2. So as the x increases by 1, the y is multiplied by 2. So the function is exponential. The key here is the multiplication on the y. We call this a geometric sequence. Example 2, evaluating exponential functions, math with Mr. Williams. Evaluate each function for the given value of x. So here for a, we have y equals -2 times 5 to the x exponent. So the x is going to be 3. So let's go ahead and write down our function here. And now we're going to substitute 3 in for the x. And now we're going to evaluate the power. And now we're going to multiply this out. And finally, -2 times 125 will give us -250. All right, on to B. So we have y equals 3, parentheses, 0.5, in parentheses with the exponent of x, where x is -2. So first we're going to write down that function again. Now we're going to substitute the x in. So we see here that we have a 0.5 or 5/10. What we're going to do is we're going to turn that into a fraction before we begin the multiplication and using our exponents. All right, so now we have y equals 3 times 1/2 to the -2 exponent. And we know what that means. We need to flip our fraction the other direction. And now we can just do 2 over 1 times 2 over 1, giving us 4. And 3 times 4 is 12 for our answer. Example 3, graphing y equals ab to the x exponent, where b is greater than 1. Okay, so graph f of x equals 4 times 2 to the x exponent. Compare the graph to the graph of the parent function. Describe the domain and range of it. Okay, so we have several things to do. So first, let's identify what the parent function is. Okay, so the parent function is this little part of that function. So we are going to call that the graph of x. We're going to use a g this time instead of an f. And we're going to make that 2 to the x power. That is our parent function. All right, so we're going to compare the function of x that equals 4 times that to that parent function. The only difference is that 4 sitting out front. So our first step is to make a table. All right, so we're going to go ahead and write down our function. And we're going to substitute each one of the numbers here for x. So we're going to start with -2 for the x. And again, I see a negative exponent. So what I'm going to do is I'm going to flip the number inside the parentheses. All right, so now we have 4 times 1/2 to the exponent of 2. So let's evaluate the exponent. And now we do our multiplication. So the function of a -2 would equal 1. All right, let's go on to where x is a -1. Okay, so we have a negative exponent again. So we just do the reciprocal of the number inside the parentheses. We're going to evaluate our exponent. Now we're going to go ahead and multiply our whole number times our fraction. So the function of a -1 is 2. All right, let's go on to 0. So the function of 0 equals 4 times 2 in parentheses to the 0 exponent. So let's evaluate that exponent. And we know that any number to the 0 exponent is going to give us 1 as an answer. And 4 times 1 is 4. So the function of 0 is 4. Okay, so now we're going to evaluate where x equals 1. All right, we're going to evaluate the exponent. There's 1, 2 there. Now we're going to multiply. So the function of 1 is 8. All right, now we're going to evaluate where x is 2. So we're going to write our function. We're going to evaluate our exponent. And now we're going to multiply. So the function of 2 equals 16. So now we completed our table. Now we're going to plot those ordered pairs that we have. Remember, to plot something, we have it in format of x comma y, or in this case, x, and the y is going to be that f of x. So our first point will be a -2, 1. All right. And so our next one would be a -1 up 2. So we start at 0, walk to the left 1 space, and then up 2 spaces. All right. And our third ordered pair would be 0, 4. So we start at 0, and we go up 4 spaces. All right. And our fourth ordered pair would be 1, 8. So we go to the right 1 space, and then up 8. All right. And our last one would be 2, 16. So we go to the right 2 spaces and up 16. Now we draw a curve through the points. Okay, and now we're going to compare that to our parent function. So we have the parent function, -2 equals 2 to the -2 exponent. All right, so let's evaluate the exponent. All right, so we got 1/2 times 1/2 equals 1/4. All right, let's plug in our -1. All right, let's evaluate the exponent. All right, into the first power. Okay, any exponent of 1 just leaves us our number. So our answer would be 1/2 on the 0. All right. So now we have 2 to the 0 exponent would just be 1. Okay, now on to 1. All right, into the first power is that number. The function of 1 is 2. Now on to our last one. So we have the function of 2. So we have 2 squared. Let's evaluate that exponent. All right, and that gives us 4. Let's go ahead and plot these on the graph. All right, so first one's at -2 and 1/4. All right, our next one is going to be at -1 and 1/2. And then 0, 1, and then 1, 2. And our last one will be at 2, 4. Now we draw a line through our points. Okay, so we have the graph of f is a vertical stretch by a factor of 4 of the graph of g. The y-intercept of the graph of f, 4, is above the y-intercept of the graph of g, which is 1. From the graph of f, you can see that the domain is all real numbers, and that the range is anything greater than 0. Example 4, graphing y equals a times b to the x exponent when the b is greater than 0 and less than 1. Math with Mr. Williams. Graph f of x equals -1/2 to the x exponent. Compare the graph to the graph of the parent function. Describe the domain and range of f. Okay, so let's deal with the two functions. So let's do with the first one they gave us, which is f of x equals negative, and this time we're going to put a 1 in here, 1/2 x. All right, so now we're going to show the parent function. We're going to call it g of x. So g of x equals 1/2 x. All right, and the only difference is that -1 that's sitting out front, and that is your y-intercept. So let's go ahead and deal with the f of x. Let's go ahead and deal with the parent function first this time. So we're going to start off with that -1. All right, so we have g of -1 equals 1/2 to the -1 exponent. We know what that negative exponent, that means flipping or the reciprocal of that fraction inside. So we have g of -1 equals 2 to the first exponent. And now we have g of -1 will give me 2. All right, on to 0. So we have g of 0 equals 1/2 to the 0 power. So we have g of 0 equals 1/2 to the 0 exponent. The 0 exponent just means that it's going to turn everything into a 1. So g of 0 is 1. All right, on to 1. So g of 1 equals 1/2 exponent of 1. And 1 of that is going to give us 1/2. All right, now g of 2. So we have g of 2 equals 1/2 squared. So g of 2 equals 1/2 times 1/2. 1 times 1 is 1, and 2 times 2 is 4. So our answer would be 1/4. All right, let's go ahead and graph that. So we have the x is at -1, and the y, or g of x, would be at 2. Okay, next we have 0 and 1. So we have the x would be 0, and the y, or the g of x, would be 1. And then we have 1, 1/2, and then we have 2, 1/4. Now we're going to go ahead and draw a line through it. All right, let's go ahead and try to find the f of x now. All right, so the first one is f of -1 equals -1 times 1/2 to the -1 exponent. We know that -1 exponent is going to flip or use the reciprocal of that fraction, giving us f of -1 equals -1 times 2 to the 1 exponent. And we know that the number to the 1 exponent is going to give us 2. And now we have negative 1 times a positive 2 will get us a negative 2 as a result. Put that in our table. All right, now let's go find f of 0. All right, so we have f of 0 equals negative 1 times 1/2 to the 0 exponent. Anything to the 0 exponent is going to give us 1 as an answer. So now we have negative 1 times 1, which will get us a negative 1 answer. All right, on to f of 1. All right, 1 times anything is its number, and a negative 1 times 1/2 would just give us a negative 1/2. All right, lastly, we have f of 2. So we have negative 1 times 1/2 squared. And 1/2 squared is just 1/2 times 1/2 times that negative 1. 1/2 times 1/2 is 1/4. And then 1/4 times a negative 1 would give us negative 1/4. All right, let's go ahead and graph it. So we have a negative 1 and a negative 2. Then we have a 0 and a negative 1. Then we have a 1 and a negative 1/2. Then we have a 2 and a negative 1/4. All right, let's go ahead and draw our line through it. Okay, so now we have both our graphs done. So the graph of f is a reflection in the x-axis of the graph g. Basically, it's the reciprocal of it on the other side, the flipping of it. From the graph of f, you can see that the domain is all the real numbers, and the range is y is less than 0. Example 5, graphing y equals ab to the exponent x minus h plus k. Graph y equals 4 times 2 to the exponent of x minus 3 plus 2. Describe the domain and range. Okay, so an important point to look at here is to graph a function of the form y equals abx minus h plus k, begin by graphing y equals abx. Now this is going to be key for us. Then translate the graph horizontally h units, horizontally means this direction, and then vertically k units. So up or down, k units. So the first thing we're going to really work on is substitution again. So we're going to go ahead and graph the ab to the x exponent first. So y equals 4 times 2 to the x exponent. The first exponent would be negative 1. We know the negative exponent means that we're going to use the reciprocal of the number inside the parentheses. And 1 of anything is that number. And a half of 4 is 2. Our next one is 0. And 0 of anything is 1. And 4 times 1 is 4. All right, on to 1. Anything with an exponent of 1 will be that base. So 4 times 2 is 8. Let's go ahead and graph it. Our first one will be negative 1, 2, then 0, 4, then 1, 8. Let's go ahead and draw a line through that. Okay, now we're going to move it h spaces. So the h is 3, so we're going to move it to the right 3 spaces for each one. So we'll start with the first dot. We're going to move it to the right 3 spaces. 1, 2, 3. And then we're going to move it k spaces up. So 1, 2, and there will be our next dot. Remember, for our next dot, we're going to move 3 to the right because the h is a 3. 1, 2, 3. And then we're going to move up 2 spaces. 1, 2. For our last dot, we're going to move 3 spaces to the right. And then up 2. Now, because of all our movements, we're going to have to really think about where our range is. So our range, because we moved it k, which is 2, means it's going to be anything greater than 2 at this point. So I'm going to come back over here to my graph. As I'm connecting my dots, the line should not go below 2 because the range is y is greater than 2. All right, and my domain is all real numbers. So in summary, when they ask us to graph something of this nature, remember we go back and we graph the abx, and then we move it to the right by whatever the h is, and then we move it up or down based on whatever the k is.